Our project is entitled External Stimulation with Bluetooth Trigger. Its purpose is to help aid patients with dysphagia or a difficulty in swallowing. It is made up of 3 hardware components: the transmitter, the receiver, and the stimulator. All of these are governed by a Java application, which Kyle will go into more detail about in one moment. For a quick hardware overview, the transmitter consists of a printed circuit board which contains pads to attach pressure sensor leads, as well as an ATmega 328 microcontroller. Also attached to the printed circuit board is an external oscillator as well as a voltage regulator. Interface to this system is the Roving Networks RN42 Bluetooth transceiver used to communicate with a personal computer as well as the receiver. For the receiver hardware, shown here, we are using an Arduino Uno for prototyping purposes as well as the RN42 Bluetooth transceiver. In practice, for size constraints, the Uno would be exchanged for a smaller microcontroller, such as the Arduino Pro Mini.
Now for the Java application overview. First, both the transmitter and receiver must be connected to the computer via the computer's Bluetooth devices. Then the application can be started. When the application first starts, it will search the computer for Bluetooth devices and populate the drop-down boxes with the found devices. Then both the transmitter and receiver can be connected to the application. Once both devices are connected, the calibration can begin. When the Java application starts reading the data, a 2D mouth visual will appear. This mouth visual starts with 6 small blue dots, each representing a sensor in the mouth transmitter. When the sensor is pressed, the dots will change in both size and color to represent the pressure received on the sensors. After the data collection is complete, a graph of the data will be displayed for a quick look at the run. The data can then be saved into a text document. This will allow the user to later import the data into Excel or MATLAB for further analysis on the swallow. Next, we will run the calibration again and send the max reading over Bluetooth to the receiver. As you can see, after data reading has occurred, several variable fields pop up which will allow us to tune the wave the stimulator outputs. First, the user can select what % of the max reading triggers the stimulator, followed by the amplitude of the wave, next the frequency, and finally the pulse width. Once our fields have been filled out, the user can press the Send to Receiver button. This will send the max sensor reading, the Bluetooth address of the transmitter, and the simulator waveform specifications over Bluetooth to the receiver. The Java application will then disconnect from both the transmitter and the receiver to allow the receiver to communicate with the transmitter. This concludes the software overview. Next, James will give an overview of the simulator, and a video will be shown of the waveform when the mouth sensor exceeds its stored threshold.
Once the stimulator receives an attempt to swallow signal from the receiver, the circuit functions as follows. A passive low-pass filter array, shown in the red oval, performs the initial pulse-width modulated wave to analog wave conversion. This signal is then passed through a high-pass filter and a difference amplifier, shown again in the red oval, which isolates the noisy ripple voltage and subtracts it from the signal. This filtered signal is then passed through an amplifier as well as a DC bias removal stage, which removes any DC voltage associated with the signal. Again, the signal is passed through a high-pass filter and a difference amplifier to remove any ripple voltage. For our modeling purposes, the potentiometer circled in yellow models our body. The op-amps circled in green are a feedback loop which reformats the signal so it can be properly read by the microcontroller. Ultimately, the waveform shown on the right represents the filtered signal delivered to the patient. In this video, you will see a waveform show up on an oscilloscope in real time when the swallow thresholds have been crossed. This completes the process of aiding a patient in swallowing.